And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we're talking about PeVatron source. Yeah, a PeVatron source. Peta-electron volt, energy from space, sunspot report, as well as a geomagnetic storm forecast, massive blizzard for Colorado and Wyoming forecast, and more in today's daily space weather. So here, looking at the sun in colorized magnetogram to see Sunspot 2809 has evaporated. This sunspot group here, it was beta class yesterday, and now it's nothing class. No more umbrae, although we do still see a large umbra associated with Sunspot 2808. Here's another view. It's the colorized magnetogram as well as 171 angstroms. A little bit of activity up here. And that plasma has splashed back down onto the chromosphere. We don't see any coronal mass ejections. And we'll show you some more solar imagery toward the end of the video. Next, let's orient ourselves. And by the way, here at the Smash News Network, we prefer our viewers to be oriented, not disoriented by nonsense on YouTube. And so here's a view of the solar system. You can see Venus swinging around at the backside of the sun, Mercury chasing it down. There's where we expect things to be on the 19th in 1 week. I think new moon is tomorrow. Here's a star chart. I like to face mine to the south. If you want to build your own, you can head to in-the-sky.org, put in your location, face it whichever direction you want. Are you facing west? Well, turn your star chart to face the way you're facing. And I've highlighted Polaris today, and I've also drawn in the ecliptic, which is this yellow line. Today the sun will be going through Sagittarius and Ophiuchus and Libra and Virgo and Leo. I don't know if you care. The 10.7 centimeter radio flux now at 78. And here is that in context. The radio flux is the radio output of the upper chromosphere and lower corona, the sun's atmosphere. And this black line here is the 10.7 centimeter radio flux. The red line is the sunspot number, and you can see how proportional those indeed are. And we are expecting to see an uptick in the radio flux very soon. That's a bit of a forecast, I suppose. Speaking of forecasts, we see a geomagnetic storm forecast early for tomorrow morning. So tomorrow, Saturday the 13th, we're expecting a minor G1 geomagnetic storm here. A KP of 5 forecasted by NOAA there first thing tomorrow morning. Some geomagnetic unrest to close things out tonight. And that's from a coronal hole wind stream, which is on its way. And it's from this coronal hole right here, associated with the South Pole. Let's talk volcanoes. As there's been a volcanic uptick, we covered it yesterday. And now it's time to cover it again because there's been additional ticking up of volcanoes. So we've seen Sangay erupt in spectacular fashion. Let's do the whole list. Etna. Looks like it's about to do another paroxysm, currently producing a 14,000-foot plume of volcanic ash. Please don't pole vault the caldera. That would be the 12th paroxysm if it does occur, starting on February 16th and continuing for nearly a solid month now. Sakurajima at the Isle of Kyushu, Japan, exploded. Unknown volcanic ash cloud there. Mount Taal in the Philippines, producing over 1,000 tremors since the 13th of February, as well as significant sulfur dioxide emissions. Mount Ibu, 7,000-foot ash plume above the Indonesian volcano. Sinabung exploded, 10,000-foot ash plume there. Semeru exploded, 14,000-foot ash plume there. And Kilauea's been doing some activity as well. A lava pond as well as some lava flows happening around Kilauea, minor changes in the geometry of the Western Fissure, Popocatépetl exploding down there in Mexico, 19,000-foot ash plume there, Pacaya exploding in Guatemala, and Sangay is the largest volcanic activity of the past 24 down in Ecuador, produced a 41,000-foot plume of volcanic ash, fertilizing the soil around the area, as well as injecting sulfur dioxide into the atmosphere. An impressive 25 million kilograms, or 25 kilotons, of sulfur dioxide estimated to be in the plume, and we're unable to detect Sabancaya. Please do not square dance around the caldera. And here's another reason to have windy.com. We've brought up the sulfur dioxide map here. You can bring up all kinds of different atmospheric measurements. Sulfur dioxide, so Sangay is down here in Ecuador someplace, and you can see how much sulfur dioxide is there. Also, I would note how much sulfur dioxide coming out of Kilauea. And indeed, it looks like Mauna Loa as well. So yet another reason to check out windy.com. They've got a great mobile app also. Let's talk about earthquakes. And here's a little quote from an article you can find today on phys.org in the Earth section. Phys.org's Earth section features this article, which is entitled Fukushima: Why We Need to Look Back Thousands of Years to Get Better at Predicting Earthquakes. And to sum it all up, we can't currently predict earthquakes, giving exact times and dates of when and where they will occur, not to mention their magnitude, and it is not clear if we ever will be able to do so with precision, at least until we understand the mechanism. It's part of the purpose of our channel, to understand mechanisms, predictive phenomenon, helping us to do things like forecast. Again, that article entitled Fukushima: Why We Need to Look Back Thousands of Years to Get Better at Predicting Earthquakes. And let's take a look at the most current earthquake scenario. And we actually had the largest of the past 24 happen just as we're doing show prep. So this 6.0 just happened. A 6.0 magnitude quake near the Loyalty Islands there. In Oceania, the deep quake earthquake capital of the world. Let's go up the list and see what else has been happening over the past 24 hours. Small deep quake near Dominica, once again another Caribbean deep quake. And tons of earthquakes around New Zealand, the seismic hotspot of the world. So largest quake of the past 24 happened right as we did show prep. Here's another deep quake in western South America. Another deep quake in western South America. Almost the same location there, a slightly smaller magnitude and a slightly deeper depth. A very deep quake struck near Fiji. A 5.8 magnitude at nearly 560 kilometers just to the southeast of that 6.0 that just happened while we did the live stream. Also a deep quake at Vanuatu, northwest of where that large quake happened. Nicaragua saw a deep quake at a 4.8 magnitude and nearly 160 kilometers depth. And here's that 6.0. Let's take a look at the location of that. And that happening out in the ocean there in between New Caledonia and Fiji. And we've seen quite a lot of activity there. Again, that's a 6.0 magnitude quake happening as we did the daily space weather. Getting back to some data from space, the GOES-16 makes its measurements in space at the ionosphere level at about 300 kilometers of altitude. The F ionosphere layer is where it makes its measurements. And here's the 3-day chart from the GO-16. We don't see any solar flares. We're not going to see any proton strikes either. We would have let you know ahead of time if there were coronal mass ejections headed to Earth. It's yet another reason why we have the channel. The GOES magnetometer showing some incredibly low readings here over the past 24. The past several hours saw a reading as low as 55.8 nanotesla. So some very low readings there around midnight local time. And for you new viewers, the N's and M's mean noon and midnight local time for the GOES-16. So some very low readings. And again, there is a plasma stream on the way, which is responsible for those low readings. Plasma has the ability to block our magnetic sensors. As the plasma heats up and orients to magnetic fields, it also acts as a magnetic insulator. So here is the diagram of the heliospheric current sheet. And before I go on, let me just check the life of the stream here. We are streaming live at Twitch. Twitch.tv/smAsho. So here's the current sheet. And the current state of the current sheet is that the Earth is in a south pole current sheet, shown here in red. Where we expect to be in the foreseeable future. And we'll let you know if that changes, and it can. Keep in mind this data is about 2 hours old. Here's a line of sight coronal hole plot, and you can see this coronal hole down here in red. That's the one that's forecasted to cause a geomagnetic storm early tomorrow morning. Second coronal hole rotating in here farther to the east. You see that right there. That's closer to the equator, and it may be more geo-effective. We'll have to keep an eye on that. And when I say ion, well, the pun is intentional. Speaking of ions, the real-time solar wind has recently shifted. As we saw the BT-BZ, and this top frame here, the white line is the BT, which means the total magnetic field. The BZ is the orientation of that magnetic field to one of the poles. So when you see a negative BZ, the south solar polar field is contributing a greater amount of magnetism to the BT. We saw it get as far as -8 with a BT of 8. So total field 8, very south pole oriented there at -8 for the BZ, the magnetic orientation. And then at the same time, we saw the phi angle shift here. So the phi angle shifted into this 250-degree region. That's the orientation of the incoming material, the incoming solar protons, hydrogen nuclei primarily. And we see a very low solar wind density here, having come up off of its highs slowly to about 8 protons per cubic centimeter. Current solar wind speed about 344 kilometers per second. And we're expecting to see an increase in those. Preceding the coronal hole wind stream, we should see a more significant uptick here in the density, as well as a downtick in the density followed by an uptick in the solar wind speed, the telltale signature of a coronal hole wind stream. So that combination of things has gotten the KP index up to 3. And the KP index is a measurement of global geomagnetism, if you weren't aware. And thanks to all you new viewers. Now we're going to look at some geospace magnetosphere movies. We're going to look at the velocity of particles in the geospace. And you can see some high velocity regions there. That is particulate solar protons being accelerated back into the solar wind. And you'll see this at the beginning of coronal hole wind streams regularly, preceding them actually, as the local environment contributes back to the main solar wind. Here's the density. You're looking at literally just protons per cubic centimeter. The range is only 0 to 4 protons, and keep in mind this shows low density regions in white and high density regions in dark blue. Each one of these frames is 4 hours of data courtesy University of Michigan. So there's the density and here's the pressure. And this is mainly magnetic in nature here, folks. This has to do with the shifts in the BTBZ, not the small uptick in the solar wind density. So chiefly magnetic effects here. Now you're looking at the pressure in nanopascals, the magnetohydrodynamic pressure. Again, it's 4 hours of data. Next, we'll look at ground magnetic perturbations, as we've seen some ground magnetic perturbations. So coming closer to home, looking at the Earth's B field here and changes in it, also in nanotesla. I would note the apparent size of the magnetic perturbation areas in the southern hemisphere. They look as large as the northern hemisphere, which is known to have split into 2 geomagnetic poles. Has the southern geomagnetic pole split into 2 as well? If not, why do we see so many perturbations there south of South America when the main south geomagnetic pole is someplace down here, south of Australia? We'll show you the global view of that as well, which will give you a better concept of where those are located. So the Earth currently has 2 geomagnetic poles, one over Canada and one over Siberia. And the net north pole is someplace between Greenland and Svalbard, about here. Svalbard. And let's advance that. We don't want the video to be too long. We want to show 4 hours of data and then move on with life. Anyway, there's the current geomagnetic excursion map. It's 4 hours of data. Again, we are streaming live to Twitch thanks to our viewers over there, twitch.tv/smAsho. We don't always stream live to Twitch, but sometimes we do. Other times we stream live to YouTube. And thanks to all of our viewers over there. Please don't forget to press like and subscribe if you're viewing on YouTube. We need the views, as the likelihood of these videos continuing to exist and be publicly visible go down with every passing day. So thanks everybody who shares on your social media, etc. It may be futile, but in any case, thanks regardless. As we've seen our subscriber count hover between exactly 1,740 and 1,750 subscribers for pushing 2 weeks now, where it's gone from 1740 to 1750 to 1740 to 1750 to 1740 to 1750. I'm sure that's completely natural and organic, folks. I'm sure it's got nothing to do with algorithms, right? We're also on BitChute. There's exclusive content there. And let's do a cosmology segment, because there's some interesting cosmology stories to cover. So let's cover them here at the Smash News Network, least busted name in news, which is probably why nobody wants to watch the videos, because we don't talk nonsense, we talk facts. And apparently YouTube algorithms aren't big on facts. So today's cosmology segment is going to start out with number 6 of our mission. You can read more about our mission at smashomash.com/forum/mission. It's to assist mankind by advancing the study of predictive phenomenon in order to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. One of those adversities has been a pandemic. And welcome to the 1-year anniversary of the World Health Organization declaring COVID-19 a pandemic. If you want to read more about that, head to smashomash.com/forum. It'll look like this. And we've got the coronavirus thread now stickied in every forum. So any forum that you click on, whether it's cosmology, earth and geophysics, the free-for-all, the general science, etc., you'll find the coronavirus thread stickied. We stickied it to global. It's a global sticky. So you'll find it everywhere, coronavirus. It's 34 pages. And what it's done is it's created a timeline of unaltered stories that we painstakingly copy-pasted into the forum, so that no matter how much the articles were scrubbed or altered over time, we've got the originals as they were posted on those days, as well as links and commentary. You can find, again, all of that at smashomash.com. Do it before it disappears or gets stuck behind a paywall, which becomes more and more likely every day. So today we're going to talk about a supernova remnant. Now, we talked about one yesterday, so maybe watch yesterday's daily space weather video as the cosmology segment was integrated. Today we're going to be talking about supernova remnant G106.3 plus 02.7 because it's showing up in the science wires today. Why? Well, because of cosmic rays. We'll get back to that in a minute. First, we're going to show you some current cosmic ray monitors. Here is Apatity in Barentsburg, and you can see a significant uptick here at the Apatity neutron monitor over the past 30 days, a significant upward slope there at the Apatity neutron monitor. Barentsburg, however, does not agree. It's a tiny uptick over the past 30 days there at Barentsburg. Let's go someplace farther south. How about Athens, Greece? That's farther south than Apatity and Barentsburg. There's the Athens neutron monitor and a small uptick there over the past 30 days as well. Next, looking at Mexico City, going even farther south. Small, tiny uptick there at Mexico City as well, mostly flat over the past 30 days, rather. And next, we'll look at 3 more to bring our total to 7 cosmic ray monitors. Here's Oulu, Finland. Small uptick there over the past 30 days. Here's DOMB, Antarctica. Small uptick there over the past 30 days. And DOMC, Antarctica. Small uptick there over the past 30 days. So we just showed you an increase in cosmic ray flux over the past 30 days. Pretty much a global average there, looking at 7 different neutron monitors. And they're essentially real-time data. Now, before we talk more cosmic rays, another interesting article here, the New Vacuum Solar Telescope, a Chinese telescope at the National Astronomical Observatories of Chinese Academy of Sciences, created a detailed, essentially an electrical schematic here, of the magnetic reconnection that happened back in 2013. And let's see if we can get that a little bigger on the screen here. Anyway, there's a diagram of this filament situation that happened. If you want to read that article, that is on phys.org in the Astronomy and Space section. The magnetic reconnection associated with rapid release of magnetic energy and its conversion to other forms of energy in magnetized plasma systems throughout the universe, or in this case, in between the chromosphere and the corona. So, now we're looking at the Cygnus cloud, as there appears to be cosmic ray flux coming from Cygnus, and you'll find this article all over the Science Wire as well. It turns out that the highest energy cosmic rays are coming from star clusters and not from supernovae. Now, some of us, like our channel, might have informed you of this before, as we've been talking to no avail about Cygnus X3, the brightest intrinsic object visible from our solar system in the entire galaxy. The brightest intrinsic object in the whole solar system is a star called Deneb. And it's so bright because it's a Wolf-Rayet star that has a more massive object orbiting it, creating a massive cloud of ionized dust and gas. And one of the relativistic jets from that massive object is pointed directly at your face. Especially if you're in the northern hemisphere, you've had material from this probably go directly through your head throughout most of your life. But in any case, this one is expected, this area, this Cygnus shell, is estimated to be about 5,000 light years away. And it turns out that supernovae do not have the sort of chops required to be these sort of cosmic ray sources. So perhaps have a read. That's also in the phys.org Astronomy and Space section. As we're talking about PeVatrons, yes, peta-electron volt gamma rays created when massively accelerated particles strike supernova remnants. It's not the supernova itself, folks. It's the material left behind being struck by ultra-high-speed particles. So this is a SciTech Daily article. It's talking about the same thing, PeVatrons. So maybe have a read there as this is the most energetic stuff that there is from space, and we'll actually have to upgrade one of our forum, our smashamash.com/forum sections, because we actually have a section entitled The Most. And if you want to check out more information about cosmology, head to the Cosmology Forum at smashamash.com/forum. And that's today's cosmology segment. Again, don't forget to press like and subscribe if you enjoy the content. Now it's time to continue back to the regularly scheduled daily space weather. Let's go. Next, we're talking about electrons. Here's the one-year chart of the relativistic electrons surrounding Earth. This is what's been going on in terms of electron flux in the ionosphere. It's a one-year chart. You can find it yourself at solon.info. Don't take my word for it. And here's a 3-day electron flux chart. And we see a dip here, having gone into warning levels the past 2 days. And our patrons are probably well aware of that as we send out alerts to our patrons. Here's the electron forecast model. And we're expecting a downtick here associated with the coronal hole wind stream. I would tend to agree. Maybe even a larger downtick than that, maybe down here. The green boxes are the forecast, and the yellow diamonds are not Lucky Charms marshmallows. Those are the observations. Here's a total electron content forecast, and this is going to show you some minor anomalies here, some blobs of high-density electron regions at nighttime. Nothing to write home about. This will show you GPS errors as well, folks. Largest GPS errors occur around the equator at noon. Here's a diagram of the atmosphere. Feel free to pause if you need to. Keep in mind altitudes are in kilometers, and this is the F ionosphere layer where the GO-16 makes its measurements. Here's a slice of visualization of just the ionosphere layer. And we would see major anomalies if major anomalies were happening. And we're supposed to be looking at a full day of data here, not just 6 hours. So let's reload. And give it a moment. We are streaming live. Thanks to everybody who views our YouTube live premieres. We enjoy chatting with our viewers, especially when those chats don't evolve into complete nonsense. And by the way, regarding complete nonsense, nobody is banned or blocked or muted on our channel and never has been. In any case, we see some charges up here of the ionosphere over places like the Indian Ocean. No real surprise there. Here's the latest image coming in at 9:30 Universal Time, and you can see that 14 megahertz region there, the vibrational frequency of that portion of the ionosphere. Next, let's go to meteorology. I would note that this cyclonic system right here has degraded as I forecasted it would yesterday. Perhaps you noticed yesterday's daily space weather video, or perhaps you didn't. And you know, maybe you're doing yourself a disservice by not watching the content. I don't know. If you want to know what's going on in space, you should probably watch the content before it disappears entirely. So here are the jet streams of the eastern world. And again, that system there, here are the surface winds. You can see that cyclone has reduced in intensity a little bit there. It all has to do with its interactions with the jet stream. I won't get into it. That's for a meteorology segment. One of our many playlists at youtube.com/smashamash/playlists. Here are the jets of the western world. And we see some cold air being injected into the northern Rockies here once again, as well as pretty chaotic jet stream flows in places like South America, the South Pacific, and indeed the South Atlantic. Here's a crazy snow forecast showing up to 4 feet of snow in a large area here. Check it out, that whole region right there. That's coinciding with that white bar there. That's 48 inches or 4 feet of snow forecasted. And I'll just slide this back. It's expected to fall very quickly here. From Sunday into Monday. So that's There's Monday at 6 o'clock Universal Time. 6 Zulu is what it's saying there. 6Z Universal Time. Greenwich Mean Time. The possibility of 4 feet of snow there in north central Colorado and southeastern Wyoming. Keep in mind that's still pretty many days out. We'll cover that in future videos. Next, looking at pressure cells here right after I check the life of the stream, and everything looks just fine. Let's continue on at high speed. Here's where pressure cells are currently located. We're going to advance this into the GFS forecast. There is where we expect pressure cells to be tomorrow. This is from windy.com as well. Again, they've got a great mobile app. Pressure cells at noon tomorrow, which is Saturday. Lightningmaps.org appears like it's back up. Although we may see some missing data here, I don't see any lightning from Australia for some reason. So blitzortung.org may be a better choice here. Blitzortung.org powers lightningmaps.org in the first place. Anyway, there's a real-time lightning map. Here's a map of the lower 48's cloud situation, even though it's too dark to see clouds right now. We use the shortwave radiation map, part of the NASA GOES interactive weather satellite suite. We see a breakup of low clouds here a bit over the Atlantic Ocean. Here's a water vapor map. And there's the cloud layer. And there's the water vapor map. Again, if you're seeing the Doppler radar and it's looking a little bit oddly, check out the water vapor map. It'll probably provide insight. And again, there's the U.S. Doppler radar map. Thanks to our patrons, a true source of funding for the content. Please consider becoming a patron if you want the earliest alerts, graphics, some free music occasionally, ringtones, and other perks for being a patron. Patreon.com/smAsho. Help increase the probability that these videos will continue to exist and remain publicly visible. Next, we've got bonus features. We're going to show you the high-res colorized magnetogram as well as the intensitygram and at least one more animation of the local yellow dwarf. So bear with me while I bring that up. So here's the colorized magnetogram. Again, Sunspot 2809 has vanished. Sunspot 2808 remains. It is only an alpha class. The likelihood of major solar flares pretty low right now. There is only one umbra. You can see that North Pole umbra there in blue. Here's that same region in intensitygram. Actually, it's turned into a beta class sunspot. We see some trailing umbrae now. So while this umbra has degraded since just this morning when I woke up, we see some trailing umbrae. That increases the probability of solar flares. And let's close things out with a 94 angstroms view. In any case, thanks for tuning in, folks. Remember, stare at the sun. Don't drink it. If you do, don't drive. No matter how much big tech and the government drive you to drink, if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. And may that solar wind be at your back.